Good evening, everyone. Hope you didn't have too much aggro in the traffic. Took me quite a while to get here from New Street, actually. Earlier, half an hour. But I don't know what the distance is, but I'm here to go over something which is kind of a lost art now, and I've spoke about this at a few conferences recently. I wrote this a while ago, presented it, and then you move on to other presentations, and then I realized that sometimes you have to go back because people either forget or new people come along. And this is a problem of how Oracle manages distributed transactions and the kind of problems you might have. And just for people who don't know me, there's my email and my blog. My main role in Oracle these days is working on certification. I'm the head of the development for DBA certification exams from a technical point of view. And I also do curriculum work, speak at conferences, and so on. But this is what we'll be doing tonight. We'll be talking about distributed versus remote transactions and queries. So there are four concepts altogether: remote queries, remote transactions, distributed queries, distributed transactions, what the differences are. We'll also be looking at the big problem, which is two-phase commit and failure during two-phase commit, which might occur. And of course, since you have to be very lucky to catch a failure during two-phase commit, and you may want to practice this. Also, how you can go about practicing recovery. Just like you have a backup and recovery strategy for things generally, every DBA should have a backup and recovery strategy for this if you use DB links and you have distributed transactions. So just out of curiosity, does anyone have distributed transactions where you have updates that occur in transactions in more than one database within the same? Well, in that case, that must be part of your recovery strategy. Unfortunately, in my experience, this is not the case. It's one of these things that people just neglect. It's okay recovering loss of a data file, loss of a control file, but if you have a failure during two-phase commit, there may be problems. So we'll teach you how to do this. We'll look about manual in-doubt resolution and what the implications are for all of that. So, of course, distributed databases is one of the things that permit some of the ideal implementation that Cod Date wrote about of location independence way back when. The ability to put data where you want and make it independent, and DB links in Oracle allow us to do that. You can have your DB links, you can have your public or private synonyms, so that no one who's writing the code even necessarily has to know where objects reside. Of course, if you look at plans, you might see serial from remote, something like this in your execution plans for those people who look at that. But Oracle provides two ways to do this. We're focusing on Oracle databases not using heterogeneous services. So we have what used to be known years and years ago as gateways, which then became known in Oracle 8i as heterogeneous service gateways, and we won't be focusing on those, although you can still set up DB links to a gateway and access things remotely from DB2 or some other database as well. So a distributed database has these attributes. It has a degree of site independence, location independence, possibly fragmentation independence. You can have data joined from one place to another, so you're basically having vertical parts of data in different places as well. You can have replication independence. You might have data replicated from one place to another with various technologies as well. But underlying whether or not you use Oracle Streams or whether you used old replication in the old days, anything that's not based on redo logs, entirely was using database links in some way or another. And to some extent, if you want real-time transactional distributed updates and distributed queries, you need to have, or remote updates or remote queries, you need to use database links. And there are many different types of database links. There are private database links, there are public database links, there are shared database links, there are fixed user database links, or connected user database links. The assumption is people have familiarity with DB links, and you can have a DB link that says connect to, so that no matter who uses it, it always connects to the remote database as the same user. Or by default, if you don't have it connect to, it will connect as, or attempt to connect anyway, as the user who's logged into the local system. So there's a bit of administration that needs to be done for DB links, which is really just a prerequisite for this talk. There are some other things that you get with distributed databases. Obviously, you can have different platforms, you can have different operating systems, all the things you could see and read on the slide. And therefore, you can join up things very, very nicely. It gives you DBMS independence as well via heterogeneous services. So lots and lots of things can be independent by setting up a distributed environment. So some definitions. A remote query, a distributed query. We're going to go through some of these, so look through this list. Some of you might recognize or know the definitions of some of these and maybe not others, like transaction branches. When do we do single phase? When do we do two-phase commits? In-doubt resolution. So our goal is by the time this talk is over, you'll have a much better comfort level with these, as well as some of the things that can come and really get you if you don't prepare for them. So there's an example of creating a database link. That's a fixed user DB link, by the way. Somebody is creating a DB link, connect as HR using a TNS names called Angel. And then you can do some kind of query like that. You should know, but I'll repeat it anyway just in case. If you set, by default, the DB link needs to match the global DB name of the remote database. This is as a check against spoofing, yeah, or being spoofed. You can set that to false, so you don't need to match it, but most people will leave it on so that you have to have global DB name set to true in order to make sure that when you set up a DB link, the name of the link in your local database matches the global DB name of the remote database. And each database in your environment should have a unique global DB name so that every single database, you know which one it is, and there's no possibility of accidentally connecting to a test system instead of a live one or vice versa, and then losing your work. So we'll start with the simplest thing. What's a remote query? A remote query occurs when somebody connects either via client server or middle tier. There's a session on a database instance, and then over a DB link we query from a remote database, and all of the data we get returned is returned from the remote environment. So we don't get anything locally. And that remote query could be a single table query, it could be a join, it could be a correlated subquery, it can involve multiple tables, but they're all remote. Yeah, they're not distributed, they're in one database, but it's remote, so that you're not accessing anything locally, you're just going through your local instance and then onwards via a DB link to access something remotely. So the local instance will send the entire query. It doesn't have to do any decomposition. At parse time, we recognize that everything is remote in a particular database, so we just send the whole query. The query will get hard parsed down at the remote database as well and be in the library cache there. It executes over there. It returns row source. And if you look at the execution plan locally, you're going to see something like serial from remote. And we're just accessing all the data from the remote database. So as you can see, it can access one or more tables or views, and you might use synonyms or maybe not. You could have your table at DB link explicitly defined in the local database in the query that's being used. And the DB link could be any of these DB links that I've mentioned, public, private, single user, whatever. The key thing from an admin point of view is you could also get errors back. For example, if you have a connected user DB link, so Fred logs in the local and you're using a DB link that doesn't have a connect to using, there has to be a Fred user on the remote system as well with the same password, otherwise not going to work. Okay? And the remote instance just returns whatever data doesn't get filtered out or removed from join if you're doing a remote query that's a join. So a remote query can join 10 different tables, but they're all on the same database. That's quite distinct from a distributed query. A distributed query involves at least two databases returning rows. It could be the local database to which your instance or your client is connected to its instance, and one remote database instance, and a remote database. Or it's conceivable that you connect locally to a local database instance and you query and you get data from two different remote databases via their instances. In other words, two different DB links are used and you're accessing data that way. That becomes a distributed query. So it's a join. If you have a daisy chain, meaning database A has a DB link defined, and it's used by the client connected to A. So we access something from B. So we have a server-to-server session between a session on database A instance to database B's instance. But then inside database B, it says, well, that thing is actually remote in C. That is not considered distributed. It's still remote because C is not visible to A. C is only visible to B. So from the point of view of A, it's performing a remote query to B. And from the point of view of B, it's simply performing a remote query to C. And then, I mean, theoretically, you can daisy chain, till the cows come home, but it's not that good to design something that way. What you don't want to end up is back where you started. But to be a distributed query requires that two different databases are returning rows. So typically you get a join like this. So you have a DB link from A to B, a DB link from A to C. They don't have to be the same type of link necessarily, and we get a join. Or possibly we just have a link from A to B and we join rows from A to rows from B. Or all three of them. We have A, B, and C. A is local, B and C are remote, and we have a three-way join. And this is where some performance things come in that you might want to bear in mind. Does anyone have this, by the way? Have distributed queries the way I've just described? Just curiosity. Yes, you do. How many different databases involved?
In one query, probably three is not uncommon.
Three, okay.
Yeah.
3 or 4?
4
Oh.
unheard of.
Okay, here's an interesting thing. Prior to Oracle 8I, the way it used to work is all the remote instances would return their rows to the local instance, and the local instance would join them. But this isn't always good for business. Let's imagine I have A, B, C, and D. A is local, and D returns 1,000,000 rows, and B returns 500,000 rows, and A returns 5,000 rows locally. If we and C returns whatever it is, and if we send all this stuff back to A and then join them and throw 98% of this away, there's a lot of data being sent over the network and then removed when you join them. So there was a hint that was added in Oracle 8i called driving site, which you can use. Some of you may have heard of it. And what you can do in theory is say, well, this is where I'd like the join to be done. In the example I gave, if you know that you're going to have 1,000,000 rows from D, you do a driving site D. So we have a distributed query. We have to decompose the query. And from the local instance, part of the query is sent over the DB link to each remote database to execute the part of the query that they can do. And the local database instance executes the bit that's local, assuming there is any. And then we may have a situation where D gets 1,000,000 rows, but A sends its results over to D, and B sends its results to A, which send them to D, like that. And then we join where most of the rows are, and then we send back the results to A. Of course, it's not always straightforward. For example, if we had 1,000,000 rows passing through the filters in D and 600,000 rows in B, sending 600,000 rows back to A and then back from A over to D isn't very good. That's more than 1,000,000 rows. So there's some knowledge that you need to have as a developer, let's say, about if you're going to use the driving site, why you'd want to do it. Oracle is meant to try to work this out, but you can't always rely on the statistics, by doing remote describes and remote stats to work out, well, where's a good place to drive such a query? But it's always better if you know where the data is, that you specify the driving site. Okay, so that's a distributed query. And the next definition is a remote transaction. So the question?
Yeah, when you're doing that, obviously you can kind of test each one and figure out which is the best sort of site for it, but is there any kind of, for want of a better term, rule of thumb where above so many orders of magnitude it really starts making a lot of sense? Is there,
I don't think so. Also, data volumes can change. They can skew over time. That's one of the problems with the driving site hint, of course, is what drives well now may not drive well tomorrow. But that's the purpose of the driving site hint, is to give you the option of saying this is where I want the join to be done, and it's particular for for distributed queries. That's its purpose. But I can't give you a good rule of thumb. There isn't one. If I did, things can change anyway.
do it
Yeah.
automatically, wouldn't it?
Yeah, so Oracle, what Oracle does is, in addition to the remote describe you need to do when you have these things, it can get remote stat and find the statistics, assuming that they're reasonably accurate, and try to work out for itself where to drive it. The driving site hint is designed to try to give you the control rather than Oracle, but it isn't determinist. It isn't. If you use the driving site hint, then it's not adaptive. In other words, until you change that hint, it might just carry on using the wrong place to do the join. Remote transactions, like remote queries, only involve one remote database. So in a remote transaction, you connect to your local instance via a DB link. We do various DML statements against a single remote database, and then we commit it or roll it back. And of course, a rollback ends up applying the undo and then committing that anyway. It's worth mentioning that you don't actually ever roll back anything in Oracle. What you do is you reapply the undo, but that's additional updates, and then that gets committed. So you're basically putting back what was there before, but the SCNs move forward. Yeah. So rollbacks or commits are both commits, basically. And all of that gets done remotely, and therefore in a remote transaction, there's only one database that's going to be doing redo generation with regard to this, which is the remote database. And therefore, there's no two-phase commit. It's either the case that you issue a commit, or you issue a rollback, or you log out and there's an automatic commit being done. If there's a failure occur, it'll just work as if the front end instance wasn't there. In other words, a failure will occur, then it will just roll back. Okay? Single phase commit. So conceptually, this is very, very easy. And a remote transaction could be one single DML statement against one table in the remote database, or N DMLs of different kinds against one or more tables in the remote database. The key thing is it's one database, and that you don't do any updates of anything locally. And finally, distributed transactions are when you have rows updated in more than one place. Like in distributed queries, it could be the local database and one remote, or several remote databases without doing anything locally, or both local and remote databases. As in the case with distributed queries, we still need to decompose the statement sometimes, but it's often the case with distributed transactions that you're doing an update via DB link in this database, then another statement updates something else in another database, and another update statement updates something locally, a bit like that. So one instance is used for each remote database. The point there is when you're doing remote transactions, all the transaction branches need to go by the same instance if it's rack. Now that used to be something that people needed to look after. No, not since Oracle 11 it works on its own. The local instance retrieves the status from the remote instance for each DML, but this requires two-phase commit to be done. In other words, two-phase commit is a well-known paradigm for distributed transactions. It means that either it's the case that all of the individual sub-transactions in each database that are part of this distributed transaction, they all commit or they all roll back. What you don't want is mixed outcome. So these type of DDL and DML can be done in distributed transaction. Obviously CTAS is a DDL, but you're creating a new table, and DDLs automatically commit. Yeah, but then you have all the usual things, and you could also lock remote tables as part of this. Those lock table in a particular mode, and you could do select or select for update. So these can all be done in distributed transactions. Now, this is part or the start of some very strange things that you need to know about with distributed transactions. First of all, in a normal one instance transaction, to prevent deadlocks from occurring, the old Aura 60, yeah, Oracle walks around the memory structures of the locks to work out whether or not, A is locking B and B is locking A, or A is locking B, B is locking C, C is locking A, and you can get an Aura 60 occurring. It rolls back the statement when you get an Aura 60, not the transaction. For people who've ever had it happen before, you may be familiar with it. But with distributed environments, we have a problem still that you could end up deadlocking, but since the locks are in different instances, there's no way to walk the chains to check whether or not you're closing a loop in a deadly embrace. And so we have the distributed lock timeout, which this parameter is used for this purpose, to specify how much time you'll wait for locked resources before deciding, well, there's a good chance that there's a deadlock. And it defaults to a minute, but it's something to bear in mind when you're testing as well. A minute is it's a long time if there is really a lock, but it's something you have to work out. There's no right or wrong answer. This is what I said before about rack. Anyone here running rack? Yeah. All transaction branches involving the same database should be connected to the same instance. Okay? I had a case several years ago where a colleague of mine was doing something somewhere. I can't remember whether it was consultant or not. But to be clever, they had set up DB links from one instance to another of the same database. Yeah, to try to do something in parallel. So they were updating some rows of a table in one database instance of database A, and some other updates of some other table from the separate instance of the same database. And the system just couldn't figure out what was going on. We have these tables of DBA2 PC pending and DBA2 PC neighbors. The underlying base dictionary table is pending trans $, and it's not designed to deal with updates to the same database. Yeah? So it was a problem. It's just not supported to do this. Don't be tempted. The reason why years ago sometimes people had DB links between instances was because prior to Oracle 8.0 there were no global $. views. So anyone here who worked in the old days of the Precambrian in Oracle 7. Anyone here an Oracle 7 graduate like I am? Oracle 6, yeah. So you may remember that in the old parallel server, if you wanted to know all the sessions, there was no GV $ session. You had to go and either connect to every instance, or people would create these DB links from instance to instance, put a view on top of them, and just do some kind of union all query in the view to access all the $. This or $. that. And you could still do that, but you'd be wasting your time because we have global $. views. So the fact that there were DB links maybe in somebody's heritage from instance to instance, maybe that led them astray. Well, why don't we try using that and being clever? And it causes all kinds of weird things. They're not supported anyway. Okay? Okay, single-phase commit as a term. Single-phase commit is used in these cases, single database commits and rollbacks when you're not using DB links, so we all know about that, or remote transactions, as we described a bit earlier, or tightly coupled transactions using XA, and Oracle supports XA, which is a protocol for having heterogeneous distributed environments where different vendors all support XA. And they're tightly coupled. The local instance sends a commit request to a single remote instance. The remote instance will either say, yes, I've committed, or no, I've rolled back, like that. And the result gets passed back. Any DB links that used in the conventional Oracle way require two-phase commit. So here's some terminology for two-phase commit. This is really the brain surgery of this discussion. Each database involved performs one or more roles. It depends on the context, and also depends on whether you're daisy chaining or not. So for example, I can have a distributed transaction where A connects to B and A connects to C, but C connects onwards to D and E. So A has a kind of coordination role to start the commit going, but C has also got a local coordination role because D and E are not visible to A. So whenever you have a distributed transaction with a daisy chain, you get local coordinators as well as global coordinators in the whole business. So the client is either a middle tier or a client, and it issues transaction requests. The database server receives them. The global coordinator is where it's the originating instance for the transaction. So I'm logged into instance A. That's the global coordinator where I issue a commit. It's the one that starts doing things like prepare, forget, commit, rollback, things like that. Okay, the local coordinator only occurs if you have a daisy chain situation in this kind of configuration. So if A is connected to B, C, D, E, and F, but all of the distributed or remote databases are locally visible to A, then you have a star, not a snowflake, and therefore you don't have the need for a local coordinator. So if you're familiar with the term star and snowflake from a data warehousing point of view, it's the same concept. It's whether or not you're daisy chaining onwards. And the commit point site is the node which is the first to commit as part of the two-phase commit process. That's not necessarily the same as the global coordinator. Yeah. The idea of the commit point site is we normally prepare everyone except for the commit point site. And if everyone else is prepared, okay, we ask the commit point site to commit without a prepare. And if it can commit, it does, and everyone else does too. And if it can't, everyone else is asked to roll back. The whole idea is that doing a prepare is some work. You have to flush redo, for example. The resources stay locked. So the idea of having a commit point site is the site which has done typically the most work is the one that should be the commit point site. That way it doesn't both have to prepare and to commit. It just has to either commit or roll back. The other thing that's true about this terminology is that if you're agreed to prepare, in other words, if you get a prepare call, you return saying, yes, I am prepared. That means you're guaranteeing that when a commit call occurs, you'd be able to commit, assuming you're still there at the time the commit comes and we don't have a failure in the middle. So in Oracle terms, when a prepare comes, we flush the redo buffers, which may result in the database writer also writing things out, but we keep the resources locked. And only when the distributed transaction finally does get the two-phase commit completed does a forget occur, and the forget unlocks resources. So the commit point site is what I've described as a parameter which you may or may not recognize called commit point strength. And on the basis of this parameter, the distributed environment determines who the commit point site should be. If the commit point strength is 1 for everyone by default, then usually it's the local, the global coordinator will also be the commit point site if everyone is 1. But if you know that a database D does the most updates, you might decide, well, let's do the commit point strength higher over there and make that the commit point site. Whether or not it's materially different in performance depends on how different the amount of work that is done by each of these sites is. If there's only a difference in 5 or 10%, you know, I've updated 100,000 rows here and 90,000 there, it may not make any difference. Yeah. So, another thing is that the commit point negotiation is only able to be done between the local node and adjacent nodes. The nodes that are not visible to the local node, even if their commit point site were higher. For example, if A has 10 and B, C, and D have 20, 20, 40, so D has 40, but D then connects onwards to E and F has 100, yeah, then that only governs how we deal with that local coordination between D, E, and F, yeah? And we'll see that in a moment. So let's look at the picture. Now that we have all this terminology, we have a client to middle tier, we have the local database instance, which is also the global coordinator. And let's imagine commit point strength is 1 over here. And then we have A, B, and C, which are visible to the local database, and the various commit point strengths, as you can see. And D and E are remote from B. So you can see that commit point strength is highest in E. But what's going to happen here is the local instance, who's also the global coordinator, when the transaction is underway, there's all this handshake and says, well, database C is the highest commit point strength, so what would normally be expected to happen is at the time a commit is done, the local database sends a prepare here, a prepare here, prepares itself, yeah, and sends a commit here. But when a commit comes here, a commit comes here rather, okay? Or sorry, when the prepare comes to B, my apologies. When prepare comes to B, before returning with the prepare, it has to do the local coordination. So once again, prepare to here, prepare to here. Before returning positive to prepare, B says, actually, I have some downward database instances. B then prepares D. Yeah. B then says, oh, you can commit. Okay. If this one rolls back, yep, we got a problem, otherwise not. And then we can commit. If that one prepares okay, this one commits. So you sound like you might have something that big with 4 or 5. So again, it's hard to say. Sorry?
Work tomorrow.
Okay.
Bigger than I can do anything about.
Right. Next thing is when you have multiple databases, their system change numbers are not necessarily coordinated. Each of them still has their own SCN, but there is something called a global system change number. And it's set to all the databases participating in this distributed transaction. And each database has its local SCN. Problem is that a failure can occur in two-phase committed at various points. For example, you can have a failure where we send everyone a prepare, but we haven't committed anyone. Or we sent a prepare to everyone and we sent a commit. And the commit has occurred in a database, D, but it hasn't got its response back to the coordinator. So we don't know whether it committed or not. Yeah? So there's all these kind of scenarios that can happen. And the problem is that resources remain locked until forget is done. And they don't only remain locked in the sense of being unable to update them, you can't query them either. They're totally locked. It's totally unique for distributed transactions. That if a table has involved in a two-phase commit, until we either know that we've rolled back or we know that we've committed, all of the tables involved in the two-phase commit are locked for both reads and writes. So if one of your databases fails because there's let's say there's a power failure or some kind, and you don't have a BBU, battery backup, or there's a fire or a flood, and we wipe out a whole data center, and they're part of a distributed transaction, and it's gone down in the middle of a two-phase commit, we may have tables in the surviving databases which are unqueryable now. That is a real risk. And therefore, you need manual in-doubt resolution to unlock them. That's what I was referring to earlier by saying this needs to be part of anyone's recovery strategy, knowing how to deal with this. Yeah, so prepare, commit, and forget are the 3 parts of two-phase commit. And this is what happens in a prepare. The global coordinator sends a request to each instance except for the commit point site. The commit point, I'm asking for this prepare to be done. I've described over there what it means when we do this prepare. This is what the site does, replies with read only if no updates are done. If we didn't update anything, we've only queried, even though we're in the distributed environment, well, that means we don't have to get a commit sent to us later. After all, you could have a distributed transaction and you also query in database F, but nothing got updated there. Locks all tables in the transaction for both read and write, so no one can query them, no one can update them. Flushes redo the disk, exchange SCNs with other instance to determine who has the highest SCN. That becomes the global commit SCN for the distributed transaction. And then, of course, if you have a local coordinator, because you have a daisy chain or a star, whatever you want to call it, a snowflake, pardon me, then it recursively issues prepare to its own adjacent nodes. And everyone does that except for the commit point site, and finally that's the one that's asked to commit. If it commits, we then send commits to everyone else. If it rolls back, we send rollbacks to everyone else. At the end of all that, we send a forget, and we can unlock the tables. So there's the commit phase. The global coordinator sets the commit. If it's also a local coordinator, then it must recursively prepare. The commit point site commits, releases locks, and does a forget. And then we then have the global coordinator propagate that onwards to everyone else. Yeah? And there's the note that read-only sites are not asked to do a commit because there's no point. There's nothing for them to commit. Okay, if you're rolling back because some site said, no, I can't commit, then the global coordinator sends a commit. Let's say if the site is a local one, then it must recursively prepare. If any site is unable to commit, then it rolls back, releases locks, propagates the rollback to the coordinator. They then propagate the rollback to everyone else. And we're rolled back, and then we forget and unlock the resources everywhere else. Forget is a simple phase. Any site that's the coordinator updates the data dictionary. It will remove references to DBA2PC pending from the data dictionary. I had a lady in Germany a year and a half ago at DOG conference came up afterwards when I did this talk and said, you know, I'm working as a consultant and at this site, and they have hundreds of entries in DBA2 PC pending because they've had obviously things that have never been resolved somehow, and nobody knew about this either. And she was looking at it. She came on the talk. So I said, well, you need to manually resolve them to get rid of them. We'll talk about that later. Okay? So, in-doubt transaction failure. If you issue a standard commit or it's in the code, you might see some message like this. Ever look familiar to anyone?
Yeah, I could get like lots of them.
Oh, good for you.
No, and then I go to the DB2 PC pending tables and have a look and make sure that I've got nothing there, and I've always got nothing there, and I think, I'm really pleased about that, because I've no idea at all what I'm going to do the day it's got something in it. So
well, the curious thing is, why are you getting things in doubt then? Yeah. Anyway, look, resolving in-doubt transactions, they can be caused by various things. There are some examples. Tables remain locked until this is resolved. So the worst case scenario is that you've got a business critical system which you can't query, you can't update, nothing until you resolve this. Now that's why you need to have this as part of a strategy, that you know what to do if this occurs. So now there is a background called RECO, the recoverer, and its job is to automatically resolve things. So if the problem is that an instance went down, so the database is unavailable, as soon as you reconnect, we handshake, it says, well, I have these in doubt, I didn't know what happened. Well, the other participating instances are able to talk to it. The coordinator then looks at it and says, oh, well, actually, I sent you this commit, and it said, yeah, I did commit. So now the coordinator says, okay, they committed. I can send the commits to everyone else. We can forget about everything, unlock all the resources, we're all very happy. If the other side said, well, actually, when you asked me to do that, it failed, so I rolled it back, then the coordinator says, well, I better roll this back locally and send rollbacks to everyone else. But until the other side reestablishes contact, we can't make that decision. That should be done automatically by RECO. And here's the problem, is to test this so that you know how to handle it, you have to anesthetize RECO. Otherwise, if you try to test things and you bring systems back up, the RECO will just sort this out for you. So there is an alter system command to disable distributed recovery, which I'll show you in a moment, where you can, it doesn't stop RECO, it just puts it to sleep. So RECO doesn't do its job. And then you can practice two-phase commits failures on your own, yeah, provided you have DB links. And then if, for example, you want to practice what you would do, see, by putting RECO to sleep, you can pretend like this other remote database is never coming back, even though you're not going to destroy it. And then you can practice your manual resolution, either using commit or using rollback. So we have commit force or rollback force statements for this. So in-doubt resolution, a failure occurs during any of the phases you might have compromised data integrity. In other words, it may be that you don't know whether the other side committed it or not, but somebody has to take a decision, otherwise the table remains locked in this database and several other connected databases like you might have. Okay? So this is a list of what RECO tries to do, as I've said, paraphrased earlier. Yeah? If the crash occurs before the commit point site commits, then rollback is done when we do connectivity being restored. That's quite obvious, yeah? If the commit is sent by the coordinator and a crash occurs after the commit point site receives it, then commit should be done when the connectivity is restored, because if the commit point site was given a commit, there's no reason it shouldn't do it. Yeah? But if a rollback is sent by the coordinator and the crash occurs before the commit point site received that, then a rollback will be done. This is all what RECO does, but if RECO isn't there or can't do it because a remote database is just gone, or your local database is just gone, and you have resources locked in the remote ones, we need to do the manual resolution. And therefore, it should be done if you have in-doubt transactions that have locked critical tables, and there's no way for your business systems to carry on, and you can't afford to wait for 4 hours or a day in order to get back this remote database, assuming you're going to get it at all. Yeah? And so we need to do it. Or if one of the participating databases is lost forever for some reason, you need to do this as well. Now, to do this properly requires somebody who knows about the current state at each database and knowledge of the application and what the implications might be of forcing a commit or forcing a rollback. So you need to have discussed this with the application designer, but that may be a third-party product for all you know. This is not easy. No one said it is. Yeah, it is not easy. So the views that we have at DBA2PC pending, which is built on pending trans dollar in the base table, and the neighbors table based on two other tables. And there's also a $V global transaction view, which was a later view that came in, I think in Oracle 10, 9, something like this. And if you're uncertain what to do and you're worried, then since this is not an everyday occurrence, perhaps, if it is, you've got real problems, then you might want to contact support, and then, well, I don't know, it's probably not an everyday occurrence for them either. But never mind. DBA2PC pending, as you can see, will show you from the point of view of your own database. By the way, this is a persistent data dictionary table. It's not a dynamic performance view, so it persists after shutdown, because we need to have a view of what's pending no matter how many times we shut down. The local tran ID from the transaction branch that was in this database is there, and then there's also the global tran ID, yeah, and the state, yeah, and whether or not we've had mixed outcomes for this. If you've had a forced commit or forced rollback and there's a potential for mixed outcomes, this will stay around and you have to manually purge, yeah. There's a purge mixed procedure and there's a purge loss database procedure as well. There's also the possibility on commit for various advice to be given by the developer in the commit statement. So I'll show you that in a bit of. Then you have times and terminals and other obvious things. Okay, this is the state. Collecting only applies if you're a coordinator. You could be a global coordinator or a local one. And collecting says the node is collecting information before deciding whether it can prepare. So if we have a failure, let's say the network fails in the middle while we're collecting, the state might say, well, we were in the middle of collecting, yeah, and we're stuck there. Prepared, well, it means that we have been prepared, but we haven't committed yet. Self-explanatory. Committed, we committed, yeah, but we're still in the view at all because there may be other sites which haven't committed yet. So you might ask, well, why should I have an entry in this DBA2PC pending locally in my database when it says committed? Well, somewhere else it hasn't committed. We're still in doubt about the final resolution. And then whether it's forced commit or forced roll back. The neighbor's view uses the local tran ID, and then it says in if it's an incoming transaction, out if we were the client. In other words, in a DB link, the side that makes the connection to the remote database acts as the client. It's a server-to-server connection, but one side acts more like a client, and the other side acts more like a server. Yeah, that's what that means. And then the database column has the name of the client database for incoming, meaning I am the server, which is the database that was sending something to me. And the outgoing is the name of the DB link, which should match the global DB name of the remote database. So you have a good idea who the database is that was on the other side of this neighbor row, yeah? And of course, you can have more than one neighbor for the same transaction because you may have a star, yeah? And then you have the name of the local user, the owner of the DB link, depending on direction, and whether or not there's a request for a commit or you're prepared only, stuff like this. $V global transaction, which was a later view, shows you all global transactions that are currently visible. Okay, which branch it is, how many branches are there, what's the state of the transaction. This is more useful, I think, in XA if you're using heterogeneous distributed recovery or distributed transactions rather than just Oracle database instance to Oracle database instance. Manual in-doubt resolution. Let's again go back to a commit request that results in this in-doubt message. Note the trans ID number from the error. That is the local transaction ID. Then query the local DBA2PC pending view. Yeah? And that will give you all the other information about this particular transaction. If the state says commit, then the local database is committed. The reason the row is in there is because there may be remote databases that are still in doubt. Okay? Now you compare this with the same on the other nodes when they're accessible. And of course, if RICO has done its job, by the time you bring the other database up, it may be faster than you are, it may resolve everything, and then there's nothing to look at anymore. Unless, of course, you're playing around and you've anesthetized it by disabling distributed recovery. If it says prepared, then the local database, the one you're looking at now, for this transaction has not committed it. Okay? And then if it's not committed, then you look at the global tran ID and the commit number, examine the neighbors to find out who the other databases are that are involved. Yeah? Compare with the same on other nodes, and if the other nodes are found prepared, it's safe to commit, force commit. If other nodes prepared, of course, you could still roll them back. And when you do the force commit, you use the global SCN, not the local SCN, with a force commit statement. If you try to use the local one, you just get an error anyway. Okay, developers, and this is not that commonly known, developers can help if they know what's going on in these transactions. Of course, if they don't, then maybe it's the kind of help you don't want. And this appears in the advice column on DBA2PC pending view. So when we have this alter session, advise commit, advise rollback, or advise nothing, there may be windows in the code. So you enter a piece of the code where at this point, the developer is saying, well, my advice is if you're in an in-doubt situation in this window of code, it's better to roll back. Whereas perhaps alternatively, there might be some other window of code later on in the transaction where they may say, well, at this point, we've done enough so that if you're in doubt, it might be safer or more advisable to commit. Or they may say, well, I have no advice at all regarding to this. And the default is no advice. Yeah. So you can do alter session, or you can use DBMS transaction to do it from the middle of PL SQL code, whatever works better. Yeah. So that's one of these little obscure pub quiz type of Oracle syntax for people who like that kind of thing. And of course, whoever is doing this must know what the implications are. There's no point in giving this advice if you don't know what the implications are. It's just a waste of time. Force commit would look like this. Commit, and optionally with a comment, because the comment is visible also in DBA2PC pending. There's a comment column. And then there's an optional word work. You don't have to use it. It's just syntax. There's the force option and the tran ID. Or you can use DBMS transaction if you want to do it. Tran ID is the local tran ID. Integer is the SCN. XXX is a comment and is optional. And it requires a privilege as well. So not everyone could do a force transaction commit, typically a DBA. Same thing for force rollback. If you can read one, you could read the other. Yeah. Now, the problem is that you could have mixed outcomes. So data dictionary cleanup, if a force has been done of a rollback or a commit, you could end up with a mixed result, because one side may have done a commit and you forced a rollback, or vice versa. And in the mixed column, you'll have a yes in the DBA2PC pending view on all of the different databases involved. RICO won't clean this up even if you de-anesthetize it. Yeah, because it says it's mixed. It means you want to check this. So we have a purge mixed procedure that allows you to get rid. Is that what you're using? To get rid of these?
No, on mine, they're always empty.
They're always empty.
I get in-doubt transaction warnings, and when I go and start to have a look, there's never anything in those.
That must be because RICO is whatever is causing the in-doubt.
I think it's network time.
It's network time. Yeah, that's exactly what I was going to say. It's latency in the network, something like this. And by the time you look, it's sorted it out. Yeah, you can prove that, by the way, by anesthetizing RICO. But it's a live system.
Oh,
yeah, well, then you don't want to do that. Don't do that. Otherwise, you'll end up with job security for life. Yeah. If one of the databases involved is gone forever, we have a purge loss DB entry, because there's no way RICO can clean it up, or anyone else can clean it up. We can't commit it. We can't force roll it back. It's gone. So we just do this instead. Because if you try to recover, you just get an error message. So instead, we do this. So this is just right out of the documentation. I only put it in here for completeness, in case you refer to this later on. A lot of presentations that I do, my presentations are mixed. Some of them I write myself, some of them are based on OU content. The OU content ones I can't share online, but this I wrote myself, so it's okay. That way you have this information about what the state is, what the state of the transaction is, etc. You can read that all yourself. I'm not going to bore you by just reading through the matrix, but it's there to give you completeness in the presentation. Okay, now this is something you may or may not have heard of. This will really, it's a good way to impress your friends. How do we practice this? Well, we use a special form of the comment on commit. It's a very obscure bit of Oracle technology. Been in Oracle since Oracle 6 or 7. It's been a long time in there, but nobody knows it, or very few people know it. What you do is you disable distributed recovery to put RICO into sleep, so that even though it's there, it doesn't wake up and do its stuff. Then you start doing your updates and whatever, and then you practice all kinds of scenarios. So let's say you wanted to do practice of crashing a non-commit point site before it's prepared, but before it's been committed. Then you would do a ORA 2 PC crash test -7 as a commit, and that will just generate as if that's happened. And then you can go and practice manual resolution of this. And there are 10 different crash tests you can do. Theoretically, how many of them you can do, of course, depends on how elaborate your distributed environment is. If you don't have any local coordinators, then there are certain things you can't do. So this is something that you need to practice. People should practice this. You should practice this, for sure. Yeah, I'm glad you're here, actually. So, some very interesting things. There's these crash tests, the ability to anesthetize RICO, and the fact that your tables remain locked until this is all fixed. That's probably the biggest shock to people when they haven't heard this before, that you can have tables that can't be read, can't be written, nothing, until you resolve this problem. Now, do you want to get a call at 4 in the morning when you don't know who you are, let alone where you are, and make this decision? This has to be part of your normal kind of recovery situation if it were to happen, but it isn't, I'm afraid. Is anyone here got something documented on how to deal with? No, nobody. I've done this talk many times in the last few years, and people don't.
You just set up a job that does a purge.
Yeah.
Problem solved.
Yeah, prisons are full of guys like you. Right, so recovery strategy for distributed databases. Yeah, complete recovery. This is another thing to watch out for. Separate. Let's say that I have a point-in-time database recovery necessitated by something. Yeah, whatever it might be. I do a flashback database, or I do an old-fashioned one where I, shut everything down, I restore backups and roll forward. Whatever the case is. But those databases had participated in distributed transactions. You've got a separate problem or nightmare scenario on your hands. I've restored a database B to last night. It's now 6 o'clock in the evening today. I had to do this restore for business reasons, say, corrupt data, whatever the reason is. But database B was part of a distributed environment. Unless you also roll back all the other databases involved in the same distributed environment to the same global SCN, then you have a logically corrupt distributed environment. And I was teaching a replication course years ago, this was, maybe back in Oracle 9i days, and there was a lady from Canada or the US. She was working for a Swiss bank in Zurich. She had just joined them about 4 months earlier. She was on this course, and it came up. I was talking about, I think it was a backup and recovery course, but I was supplementing the normal Oracle stuff in there to talk about recovery from distributed environments, because our courseware doesn't deal with it, or didn't at the time. And I said, does anyone have, and I mentioned this problem, and her mouth dropped open in the back row, and she ran out of the room. And she spent the rest of the day on the phone. Apparently they had a 3-way distributed environment, Zurich, London, Toronto, I think. And they had, a couple of months before she joined, she had heard about this once she joined, that there was a case where they had to roll back one of the databases, didn't roll back the other two, because nobody knew this. And this was major international banking system of some kind. She didn't say who was affected. I said, I'm not banking with you. So that happens. It does. This needs to be something that you add to your recovery strategy as well. If you do point-in-time recover of a database, all the distributed databases have to be going back in time. Otherwise, you live with the consequences. Yeah? Unless you can identify which objects are involved and do point-in-time tablespace recover for those objects, and you want to pick them, then fair enough, try to do that. Or Oracle 12, you can do point-in-time table recover, which you may have heard of, and surgically recover those tables, but that may take you a bit of time because that doesn't do transportable tablespace, yeah? So some of you may have been fiddling around with that feature. But bear that in mind, okay? You need to recover to get those objects back to the same global SCN. Okay? So complete database recovery, distributed transaction restored to the state prior to failure. Recode then automatically resolves any in-doubt transactions. It's done automatically. It may be done by the recovering instance in rack, because you only have one instance doing recovery in rack. Table space or table point in time may be required also for corruption or logical errors. Okay, so data in other databases must be restored and recovered to the same point, as I've just said. Database point in time recovery, same thing. And so whichever way you do it, you have to get those objects to the same global SCN. That's my message. So that, plus the fact that your tables remain locked when you're in doubt, that's a lot to take on board about the dangers of having things go wrong in a distributed environment. So I didn't mean to scare everybody, but I hope that you get a flavor for why this is important, because backup and recovery is what still, along with security, I suppose, these days. Pete Finnegan is busy at work everywhere because security is such a hot topic, but we're still judged by our ability to deal with failure scenarios. This needs to be raised in everyone's consciousness if you're using distributed environments. Otherwise, a day might come when things go wrong and you're not prepared. I hope you enjoyed that. Does anyone have any questions? If you do, just think of them later on. Just send me an email. But thank you very much. I hope that you had a good fight.